Right, then we're back. And we had created the baseline for our part here. And now we'll start off by, or continue, by creating the circle for this rounded edge here. So it's going to be more or less the same principle as we used for the rounded edges on the previous part. So we're going to place a circle. And the circle has a radius of 30. So 30 multiplied with 2 to get the diameter of it. And we're going to use the same as last. We're going to set the horizontal length between the end of our baseline and the center of our circle as the radius of the circle, just to lock it into place. And in order to get some automation into it, we click on the diameter, selecting that dimension, D1 in this case, and we divide by 2. Then we need to set the height from the baseline and up to the center of the circle, and that's going to be 27.7. And now we need to create two lines, so we need the vertical line connecting the circle and the end of our baseline, and we need the line from this end of the baseline that's going to become tangent with the circle. So we open up the line option. We connect it to the end of the baseline and pull it up to the circle. And here we see that it actually shows us that it's a tangent when we put it in there. So we get a small circle with a line passing at tangentially to it. Then we connect the next line to the other end of the baseline, and we pull it up to the circle. And if I just pull it up randomly up here, it's just going to connect it to the circle. But if I keep moving my mouse pointer further up here, I'm going to get to a point where I get the tangent symbol also. So then I can connect it directly there, and it's going to become tangent. So I don't need to go up and put a tangent constraint on it afterwards. So I'm just going to click there with my mouse pointer, and we can even see that it's put up tangent symbols for both of those connections. Just let people get a chance to catch up there. Right, now we have the outline of our part, but we have a little bit too much showing of the circle. So we're going to trim the circle before we extrude it. So we go to the trim option up there. And now you'll see that I'm going to have to perform several trims here because the trim always cuts away between intersecting lines. So when I'm cutting this part, I'm not cutting this because I have an intersecting line at the bottom there. So I need to first cut this, then that part, and then that part. And once that is done, we have only the outline of the parts showing. Then we can click on Finish Sketch. And we're going to extrude it. But for this one, we're going to extrude it in both directions. So we click on Extrude. And it selects our outline here. And we're going to go up to our different directions up here. And we're going to choose the one with 2 black arrows. And once we hover our mouse pointer across it, it should give us a tooltip. Maybe I need to click it. There. Then it says symmetric, so it's going to extrude it an equal length on both sides. The dimension that we are going to give is the total width that we are going to extrude it, but it's going to do it equally on both sides. So basically we're creating a symmetry plane in the middle of it. And this one is going to be 35 millimeters thick. Then we click OK. So just to illustrate my point here now, I'm going to make one of my planes visible. So here we can see now I have a plane that's going straight through my entire part. And this plane is going to help us a bit when we're going to assemble it, because we can connect that plane to the other parts. Just going to remove the visibility of the plane again. We're missing the hole that's supposed to go through this part, and then we of course use the hole function in order to create that one. And for the placement option, we can choose the concentric one, because in this case it's going to have the same center point as the large circle which we created. So concentric. And plane is the surface that we want to start drilling on. So we want to drill on this one. And the concentric reference will be the curved edge there. And we're going to have a bit larger hole than 3 millimeters. We're supposed to have 24 millimeters going through here. And then we click OK. So this part is a typical pad eye. It's often called that. It is sometimes called a lifting lug. It depends a bit on which company you're working at and stuff like that. But a pad eye is meant to connect a shackle to, like you are going to do in your group project. So it's meant to have a shackle going through here, and then for the base plates are going to be bolted to a structure. So then you can lift the entire structure with this one. So the last thing we're going to do is to set the material to stainless steel, and then we're going to save it. So we set the material, stainless steel, and we click Save. And since this is the pad eye itself, I'm going to call this one a pad eye. And it doesn't really matter if you spell it in one word, or if you divide it in 2 words, or if you have a dash between them. That I've seen all kinds of ways of writing pad eye out there in in the corporate world. So I don't think there's a specific kind of way to write it. So now it's been saved, and we're going to create the drawing for it, or at least place all the dimensions and views in place there. So then we need to go down to iso.idw, and we're going to click Create. So again, we now have 3 different parts open, but it was the pad eye that we just edited, so that's the one that's going to be automatically chosen when we try to place our base view. So I need to rotate it a bit in order to see it from the side, and then I'll also create a projected view to get the thickness of it. And I'll check if I can increase the scale for it. That's going to be a bit too big for us. So I'll go back to a scale of 1:1. So it's going to be a bit small compared to the size of the sheet, but 2:1 again is too big, so we'll just have to leave it be. And in this case, the only kind of symmetry we have on this part is symmetry down here. But we're not going to show that, because if you have something that's cut from a plate, you're always going to have symmetry along the thickness of the plate. So there's no point in showing that one. So all we need to do is to put center marks on the curved edge and on the circle that we have. So we go to the annotate part of the toolbar, and we click on the center mark option, and we click on both the curved edge and on the hole to get both of them shown. And then we can start placing our dimensions. So I'll start off with the thickness of the pad eye, and I need to change it to method 1B. On this projected view, I'll also put in the total height of it, but I'm going to put it in as a reference. So from top to bottom, and then mark it as reference so that we get those parentheses around it. And the whole point with putting such reference dimensions in is just to make it easy for the machinist to actually measure across there, and he doesn't have to do any calculations in his head to verify that this is approximately the correct dimension. Because what's going to be the deciding factor for the height of it is going to be the placement of the center point of the hole. So if we go from the baseline and up to the center point for the hole, those 27.7 millimeters will be defining the height along with the radius. So when they're creating this cut, if they're a bit off on their tolerances, it's going to affect the total height. And then we'll put in the length over to the center point. We want it connected to be placed on the same line as this dimension. And we want the total length of the pad eye. And before we create the dimension for the hole going through here, we're going to put in also as a reference the angle in here. And in order to put in an angle, all you need to do is actually just click on 2 lines that are not parallel to each other in here. So with the regular general dimension tool, we're just going to click on the baseline and then on the other line, and you can see already just by hovering my mouse across it, it's showing me the symbol for an angular dimension. So I click on it, and it's giving me the angle. And measuring 30.26 degrees, that's really difficult. And this is only going to be a reference point for the machinist, so that he can see that he hasn't missed his mark completely. So we're going to go up to the angular unit part, and we're going to set 0 decimal points. So then it just rounds it off to 30 degrees, because that's going to be more than enough for the machinist to just see that he is approximately correct on this one. We're also going to put in the reference option for it, so that we get the parenthesis around our angular dimension. We're going to tweak this a bit afterwards, because we want the dimension to be shown on the outside of the part. We don't want the angle part to be inside, but we have to tweak some options before we actually drag it to the outside. So what I need to do now is to exit the dimension function. So I don't want that one marked blue up in the corner there. So I just press my escape button. Because if the dimension function is marked blue and I click on my angular dimension, I'm just going to open up the window again where I can set the tolerances and everything. So that's not what I want right now. First off, I'm going to show you what happens if I just try to move the dimension to the outside. So if I click and drag on the dimension, it's going to switch it from 30 to 150. And that's not what I want. So I need to keep it in here. And I need to right click when I've got the dimension marked green like this. So I'm going to right click. Then I get this menu here open. What we want to do is to... Oh, I got the incorrect menu. I hit the view instead of the dimension. There, that's the correct one. We're going to go down to the options part. And then we can see we have quite a bit of different choices in here. The fact that it's switching from 30 degrees to 150 once I move it to the outside is that we have a mark beside use quadrant. Because that means that it's going to give the dimension of that quadrant of a full circle. So if we remove that black check mark by clicking on it, now we can drag the dimension to the outside and it stays 30 degrees. But another thing that's a bit nice to do is now we've got our arrows are on the inside of our part, and if we're showing a dimension on the outside, it is more correct to have our arrows also on the outside. So then we can mark the angular dimension again. We right click to get the same menu up. We go back down to options. And then we see the top one here. It says arrowheads inside. And it has a black check mark. So if we remove that black check mark, then we get the arrowheads on the outside of our parts instead. Or in this case, what is more correct to say is that we get it on the outside of the angle that we're showing. But that's the same as the outside of the part in our case. So then we need to set the dimension of the hole. And we'll do that by using the hole and thread note. We need to switch it to method 1B. And just put it up here. And here we only have one hole, so we don't need to mess around with any quantity notes or anything like that. So then the only thing that's missing from this drawing is the title block and all of the notes and the material and everything like that. But we'll skip that so that we can get more time on our assembly. So we'll save the drawing. Here we can see the other two drawings. So we'll click save. And then I'll just make sure that I've got everything with me here. Looks that way. Then we'll go up to the new sheet up in the corner. We'll click on that one. And now we're not going to create a standard IPT file. We're going to go a bit more down here. And we can see that we have a standard in millimeters here also. And it says .iam. It also says assembly up here on the title part. And that's what we want. We want a standard in millimeters assembly. So we click create. And at a first glance, it looks pretty much like starting a new part. The difference is, up here, we have quite a few different toolbars to look at. We're going to start off by placing our parts in here. But the one that's automatically chosen here, place from Content Center, that's not the one that we're going to use, because this is a library with different standardized components. Bolts, nuts, sealing elements, flanges, and stuff like that. So that you can open up the Content Center, and if you need a specific bolt, an M14 that's 110 millimeters long, you can go to the correct ISO standard, and you can find the correct dimensions for it, and then it's going to place it automatically for you. So that you don't have to 3D model the entire bolt yourself. So you're just picking it from a catalog instead, which makes everything a bit easier when you're creating large assemblies with lots of nuts and bolts in them. So in order to place our parts, we need to open up the drop-down menu. And we're going to use the one that's just named Place. Click on that one. And then it opens up our project folder. So here's the important bit with keeping everything in one project when we're going to assemble it. Because now we can see all of the 3 parts that we've already created. And we're going to start off with placing the small base, the first part that we created. So we click on that one. And here is actually a nice thing to see also, because it tells you which edition of Inventor was used to create it in, or basically the last time it was saved. Because if for some reason you're sitting on a computer where Inventor 2017 is not working, if this part has been saved in Inventor 2017 last, then you're not going to be able to open it in Inventor 2015. Because you can't go backwards in time, you can go forwards. So a part that's been saved in 2015 can be opened by 2017. That's not a problem. But you can't time travel backwards, basically. So we're going to click open here. And right now, I'm just going to flip my view a bit so that you can see it a bit better. Right now I'm moving around my part, so it's following my mouse pointer around. One thing that is nice to do when we're putting in an assembly is that the first part we're putting in, we're going to do something to it that's called grounding it. So we're going to right click, and then we have an option here of placing it grounded at the origin, which is the center of our coordinate system. So I'm going to click on that one. And then you can see we can place more of the same part if we want to. But we only want one, so we're going to click escape to exit this one. Now I'm just going to flip my view a bit around to get to see it a bit better. Like this. And one thing that we need to notice right now is over in the browser window, we see base small, and we also see that there's a thumbtack over the icon of the part file. And that means that it's been grounded. So this one is locked into place. It can't be moved anymore. So that if I zoom out a bit here, I can't mark it and drag it around the window. So it's completely locked into place, just as if it was inside a sketch and we had constrained it fully. So it's rigidly locked. So now we're going to place the second base plate, the large base. So we go back to the place window and we find base large.ipt. And we click open. And you see this one is also following the mouse pointer around. And we want this one to be able to move around. So we're just going to place it clicking the left mouse button. So one click is going to place one copy. If you had wanted to, we could have placed several copies of it. But in this case, we're only going to use one. So for an example, if we were finished with the assembly and we wanted to also place the 6 bolts that are needed in order to bolt this one into place, then we could choose the correct bolt size and we could place 6 bolts in one go. So we'll just click escape to get away from the large base plate. And now we're going to start moving them into the correct position, or rather we're going to start moving the large base plate into the correct position in relation to the small base plate, which is stuck in where it is. And in order to move them, we're going to use constraints. So they're basically the same as the constraints that we are using in sketches, only here they are in relations to planes and surfaces instead of being points and lines. So we click on constraint, and here we have quite a few different options. We're going to focus on this first tab here, which is named assembly. So that's mainly where we're going to be. The other ones, motion, transitional, and constraint sets, they're a bit more advanced. So they can, by using those options, you can allow movement, but still keeping stuff fixed in place. For an example, rotation around an axis, or that it can move along a line for a certain length and then move back again. Like if you are assembling a hydraulic cylinder, you might want the piston and the piston rod to be able to move to the full extent of the cylinder and move back again. So that might be something that you would do inside motion here. But we're going to focus on assembly when we're working now. So we have a couple of different ways of doing it. We have the one that's called mate. And how that one works is that you're going to click on 2 different surfaces. So for an example, if I click on this surface on the large base, and then on this surface on the small base, they're going to be put together. And then depending on what solution I've got selected there, so you see the one that's marked with blue now, you can see that the 2 faces, they are facing each other, so they're going towards each other. If I click on the other one, they're going to face the same direction, so I need to tilt one around then, because both will look at the same direction, but they will be on the same line. So they will be connected to each other, but they will be facing the same direction. The next one gives you the possibility of setting them at an angle. So if we are still using those 2 surfaces, we would set them together, and then we can specify the angle. So for an example, if we want a 45-degree angle, we would put it out here or something like that. So you can set stuff at an angle if that is what you need. You can also use the tangent part, where you will select a curved surface and then a flat surface, and you can put a tangent to it so that you can actually move it along this one. You also have an insert option, which is very nice to use for shafts and bolts, because you basically choose a cylindrical part on the shaft or on the bolt, and you connect it to a hole. So it's a nice way of getting bolts, nuts and bolts and cylinders, shafts and everything in place very quickly. One that we won't be looking at all while we're working with this one is the symmetry one, but it's basically just constraining them symmetrically across a plane. So for now we're going to use the mate option, and in this case the first mate that we're going to do, we want them to be facing each other, because we're going to do exactly the one I was showing. We're going to connect these two surfaces. But as we can see in the finished object, they're not going to be touching each other. So we can set, over here on the offset parts, we can set a certain distance. And then they will first off be moved together, connected to each other, and then they will be moved apart for that offset distance. And then they're going to keep that distance. So it will be the same as putting a dimension between them in a sketch. So first off, I'm going to click on the tip of the large base. There. Then I'm just going to switch my view a little bit around so that I can hit the backside of the small base there. And it's going to be put into place there. And if you've got the volume up on your computer, you're going to get a sound once they snap into place there. So it's going to play a short sound clip. And that's just good to have, because if that sound clip doesn't play, then you know that it hasn't been put into place there. So then something has gone wrong with the constraint. So then we're going to click Apply. And if I now look at it from the side, so I'm going to flip my view a little bit. Now we can see that, yeah. Oh yeah, I hit my apply actually. I wasn't supposed to do that. I'll just go back to start again. Right, so I'm going to switch the view to the side here just to show you a little bit. So we've got two things that's not correct right now that we can see. The first one is that our two base plates, they are touching each other. They're not supposed to do that. They're supposed to have distance between them, so we're going to need to set an offset for this one. But we can also see that they're not on the same level. So we're going to have to fix that after we've put on the offset. So first off, we're going to get them moved apart. So we go up to the offset here. And the distance that we're supposed to have between them is, let's see, 24 point something, 24.3. So 24.3. And now you can actually see that they've been moved apart. So once the offset is in place, we've got them moved apart, then we can press the apply button. Now they're going to stay at this certain distance from each other. So now I'm just going to flip my view a bit again to get to show things better. Now the next task will be to get them on the same level. And for them to be on the same level, we can't use the solution option where the surfaces are facing each other. Because then if I click on this surface and then on that surface, they are going to be flipped around like this, because they are supposed to be facing each other. So I need to use the other option where they're going to be facing the same direction, because then they will be looking like this and on the same level. So I need to switch the solution option there first, so that we have the correct one. If you have the wrong one, it's not a big problem. It's going to flip the part, but then as soon as you switch your solution, it's going to flip the part back again. So it's not a huge problem if you forget to do this before you attach them to each other. So then we're going to select the top surface of both of our parts. And we could see that it lifted the large base a little bit. And if I now change my view to the side again, we can see that they're on the same level here. So I'll flip my view back, and then we can press apply. So I'm just going to exit the constraint function a little bit to show you something. You don't need to do that if you don't want to. So now we've locked it into place height-wise on the y-axis, so it can't move anywhere because it is locked into the same level as our small base. It is also locked into place along the z-axis because it has to be a certain distance from the small base. But it is not locked along the x-axis, so we can actually pull it sideways still. So after the break, we're going to make sure that these two are completely locked to each other and aligned. Right, so then we'll continue. We now need to lock our part into place along the x-axis. And in order to do this, we are now going to utilize the fact that we've made these symmetrical and we have planes crossing through them. So I'm just going to show the planes. So for the small base, I have the YZ plane for that one. To make it a bit more easy to put the constraints in place, you can actually, I'm not sure if you can put visibility on this side. Yeah, you can put visibility on there. And we can do the same for the XY plane for the other parts. And what we want now, if I look at the top view, we want these planes to be locked into the same line so that we can't move it sideways anymore. So I'm just going to get a bit better of a view here. Then we go back to our constraint function here. We're still going to use the mate type that we have used until now. And now for our selections, we'll choose both of these two planes. I'll just show once more how you got these planes to be visible. It is not necessary to have them visible because you can just click on the plane in the browser window instead. But I just did it in order to be able to show them. So you need to go to the browser window for the and click on the part itself. You need to open it up so that you can see the origin folder for that part. And then you need to look at the different planes of that part. And for some reason, you can't right-click directly on the plane and show visibility. You have to mark it, and then you have to right-click on it out in the assembly. Because there you get the visibility option down here. And then you can do the same for the other base plate. You click on it in the browser tree, open up the origin folder that's below it, and you locate the plane that is going symmetrically through the parts. And then you go into the part and you right click on the plane there, and then you can select visibility for it if you want it to be shown. So then we'll open up the constraints again. And we're going to use the mate option. And for our two selections, we are going to select these two planes. Now I can either select the plane over here, then you have to hit the edge of the plane in order to be able to select it. Because if you try to hit the middle of the plane, you're just going to hit the surfaces of the part. So you have to hit the edge of the plane. So now I'm going to select that one there. But you can also select the plane in your browser window. So you have the possibility for the second plane to go into the browser window and see the YZ plane. It's the one that's going across here. And I can click on it in the browser window also. If it did not want to move these two together, then it just means that you don't have this arrow pointing in that direction and the arrow for this one pointing in the other direction. So then you just have to switch around your solution because you have to have them both pointing in the same direction for that one. So if it didn't work at first, try switching the solution and then it's going to work. Because if I try to switch solution now, nothing really happens on mine because this doesn't work. Once that is done, we can click Apply to place the constraint there. And now I'm going to remove the visibility of these planes because I don't want those showing at all times. So I mark it over in the browser window and then I right click on the part and I click again on visibility, removing the check mark on it. And that should have removed it. Well, that was the entire part. There's the visibility. Why didn't I hit that one? There. Okay. For some reason, it doesn't want to remove visibility when we're clicking on that one, but if you click on repeat visibility, then it worked. So it's don't quite know what's happening there, but du må trykke på visibility en gang først. So you have to have tried using visibility first off in order to get that repeat visibility part. So we've basically stumbled across a glitch in Inventor because it was supposed to be able to remove them by just using visibility, clicking on it. But if you can't get it working, I figured out that if you remove visibility on the part itself, So we go in here and we remove visibility. So we make the part invisible. And we go back into the tree here and we make it visible again. We click once more on visibility, so then it's back. And then you will get this repeat visibility option, and that's going to work on the plane. So I think this is a glitch that's shown up in 2017, because at least in 2015 that works. You can use visibility directly there. Yeah. Yeah. In 15 you can right click on the plane and remove visibility, and it's going to work. Yeah. So once we've managed to remove visibility on everyone's planes, then we can continue on with the next part and place it in here. And that is one of the main reasons why I prefer to just click on the appropriate plane in the window instead of putting on visibility and clicking on it on the part. It's basically to just avoid extra work, because then you have to put the visibility on and then you have to remove it afterwards. So it's not going to take more time than just clicking on the appropriate part in the browser window. So I think we've got most of you on the same place now. So we're going to place the pad-eye parts. So we go up to the place option and we find the pad-eye file. And we're going to click open. And we're going to place this one just in a random location, because we're going to use constraints to get it in the appropriate one. And we're, of course, just going to use one of them. Now, the first thing that we're going to do is to get it on the same level as the top of our base plates. So we're going to constrain it on the height direction. So we're going to get it placed on top of there. And then I'm going to need to move my view a little bit around so that I can see the underside of the pad eye. And I'll go to the constrain option. And in this case, we really do want our solution to be that the two surfaces are going to face each other, because we're going to select the top surface of one of the base plates and the bottom surface of the pad eye, and those are going to face each other. And we also want an offset of 0 millimeters, because they're going to be in contact. So first off, we choose the bottom of the pad eye. Then we need to switch our view a little bit around. And then we'll choose the top of one of the base plates. It doesn't really matter which one. They're both aligned. So no matter which one we choose, it's going to end up in the same location. Once that is done, we can click Apply. So if I flip my view now to the side here, we can see that it's definitely not in the correct location, because it's supposed to be flush with the edge of the small base plate. So we're going to have to do something in that direction. So I'll switch back here so that I can see both of the fronts of these. And this time, we of course want both of the surfaces to be facing the same direction. So if I leave my solution like that they are going to be facing each other, then it's going to flip my part around. So I'm just going to show you that now. So I click on the front of the pad eye, and then I click on the front of the small base plate. And now it flipped it around, because I had the option set in that the two surfaces were going to face each other. So if I just change to the other solution, that they're going to be flush, then it flips it back. So then we get it in the correct position. Right, so then I'll press apply to get this one into place. And now the only way we can move the pad eye part now is back and forth to the sides like this. So now we're going to have to lock it into place that way also. Because if I look at it from the top now, we can see that we don't have it centered on the base plates. So one way of doing that is using planes again. So since we extruded this one symmetrically across one plane, we do have a plane that's going directly through it. So I go down to the pad eye part in here, and I open up the origin folder. And I look at the different planes. So I hit jackpot on the first one, YZ plane, that's the one that's going straight through my part here. So instead of making that one visible and having loads of trouble afterwards getting the visibility away, I'm just going to click on it here, and that's going to select it. And then I can go up to basically either of the base plates. It doesn't really matter. So now I'm looking at the large base plates. That's the wrong plane. I don't want to attach it to that one. So then I look at the other plane. That's the wrong one also. So then we go for the third plane, and that's the one we want. That's going to center everything. So then I click on that one also. And now it didn't want to move my parts, but that's because I have the solution of putting them flush. But it's not allowed to rotate any of the parts, so I can't put it flush right now. So I need to use the solution where they are facing each other. It might be the other way around on yours, that they won't face each other, that they have to be flush in order to for it to work. It depends a bit on how it places these arrows on your planes when you're selecting them. Once that is done, we can press apply. And then we're actually finished placing constraints. So no matter where we click now on this one and try to drag it, everything is locked into place, so none of the parts can move. So then we're going to save the part, save the assembly. We're no longer talking about a single part, we have an assembly. And I'm going to call this one pad eye also, but I'm going to add an abbreviation behind it. ASSY, which is for assembly. So it's a commonly used abbreviation for an assembly. I click save, and I might get this window up, and all it does is just telling me that it's also going to save all of the part files that I'm using. So just click OK for it. That's all right. Right, so we're quickly running out of time for creating the drawing here. So I'm just going to get to show you the drawing since I only have 5 minutes left, basically, before we need to do a break. So I'm going to show you the drawing because we have welding symbols and stuff to put in there. And you haven't done that yet. So I'm going to create a new drawing. And even though we have now created an assembly, so a different file type from a part, we are still going to use the same drawing file. So it's still iso.idw. And if you're not fully finished with your assembly parts, then you can still create your drawing because you can finish off your assembly afterwards. So you can still start on the drawing. So for the base view, it's now going to choose the assembly first, since that was the one we were working on. And I need to rotate it a little bit to get a good base view here. So I want to look at it from the top like this. And I want to have a projected view up top. And after I've placed these, I'm also going to create the projected view over on this side. But we can look a bit at the scale, maybe do a 1-to-1 scale. I think that's going to work when we start moving them around. So we click OK. So pull it a bit down here. And now I can create a projected view of this one so that we can see it from the front here. Projected view. And create. So now I've got 3 views of my assembly part. I can see it from the top, from the side, and from the front. And there's a couple of things whoever is going to weld this together needs to know. So he needs to know the distance between our base plates, because that's something he's going to have to measure and set in place before he starts his welding. So we need to put in a dimension between those two. And we're putting it as method 1B. Because then he knows where to place those plates in relation to each other. We also need to put in a symmetry line here, because then the welder will know that everything has to be centered on each other. So we'll use a center line. And from one edge and to the other. And then the last part that the welder is going to need for this assembly is the welding symbol, because he needs to know what he's going to weld. And we'll find the welding symbol beside the surface roughness symbol. So there. And in this case, we're going to place it in that corner. Make sure that we get the green dot there to connect it. And then we're going to pull it a bit up here. So here we can click once on the left mouse button and then on the right mouse button and continue. That opens up our welding symbol. Now what we're going to put in here is some information at the start of the line here. So we're going to put in A. That's one of the ways of measuring the thickness of a weld. And then on the next window, we're going to put in 3, because it's going to be 3 millimeter thick, this particular weld. And Torbjörn is going to when you get to the welding part in the mechanical design lectures, he's going to go more through this with you to show you what is what and why we are marking it in this way. But we want it to be welded on both sides, and there is a possibility here of just using one welding symbol. We don't need to place a welding symbol on both sides of the part, because we have this line up here. So our A, if I just click on the next here, then we get our A3 dimension, and it's a fillet weld, so it's a triangular weld. All of that is placed on a continuous line up top there. But we see below the continuous line there is a dashed line. And if we put in another symbol underneath here, another triangle to show that we have a fillet weld there also, it's going to end up on the dashed line. And the dashed line signifies that it's on this side of the material that we are welding. And we are going to put in this case, the same dimension there also, A3. But here you actually have a possibility of having different dimensions on different sides. So it's not always that you want to use the same thickness on your welds on opposite sides of the parts. There is also a possibility of setting the length of your welds. You can do that in these columns here. So you can set the length of the weld, and you can also set, for an example, if you have several meters of parts that are going to be welded together, you can set a short length, and you can set the amount of intervals that you're going to have. Another possibility is if you have a circular object and you're going to weld all the way around it, you can press on the corner of the welding symbol to get a circle there. Then it's going to show that the welder has to weld all the way around. So now we click OK, and we've got our welding symbol in place there. That was everything we managed to do for today. I'm going to briefly show how we put in welding tolerances after the next time we have a lecture. So we'll look at that also. The rest of the drawing will be more or less like a part drawing with notes and everything. So I'll just save it so we have it for the next lecture.